Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video, I am going to discuss about schema detection feature in Snowflake. Okay. So if you have done some work with PySpark, then you might be knowing that in Spark there is a functionality. While reading the data from a CSV or Parquet file, we can provide an option in which we can specify infer schema as true. Okay. And if we specify that, what will happen? That Spark will load the data in a data frame such that different data type it will try to infer. Okay, like if we don't mention infer schema as true, it will be by default taking all the columns, all the elements as string. But suppose you are mentioning infer schema true in Spark, then the integer will be treated as integer only while loading the data in a data frame. The string will be treated as string only. Okay, the double will be treated as double only, like that. Okay, and that is nothing but called automatic schema detection. Okay, now the same functionality nowadays the Snowflake is also providing. So today in this particular video we are going to explore the schema detection feature in Snowflake. Okay, right? So without any further delay, let's directly jump into the some fundamental theory and then we will look into the lab section. So with schema detection, Snowflake will automatically determine and return the schema of your staged file for review. Okay, so once you get the automatically detected schema, you can use that to create a table or view or external table, whatever, for your ETL or ELT framework, right? That is very useful, right? And what is the advantage? Obviously the advantage is, suppose in the external stage or in the internal stage, the number of columns present in a particular file is huge. Maybe 100 columns, 120 columns are there. Okay, that time writing the DDL for individual columns, it is a very difficult job, very boring job, right? And that's where this particular schema detection feature will help you to automate the whole process and load the data in a structured format quickly. Okay, so the advantage is nothing but it resolves the pain of handling the schemas of large multi-column file. Instead of manually, you can use this automation tool. Okay, and it will obviously in turn simplify the ingestion process, right? Very simple with respect to advantage point, right? Now let's try to understand how we can do this. Okay, so for that there are three important topics which I am going to cover. Out of that, first topic is infer schema. Okay, so what it will help you, the name is quite similar to Spark infer schema. Only thing is in Spark we don't provide underscore in the middle, just we simply write infer schema, but in Snowflake in this particular function you have to give underscore, and basically this particular one is the main function, okay, which will basically infer this schema. Okay, so it retrieve and return the schema from a set of staged files. Okay, right? So let's try to understand how we can work with this. Okay, before that, what we will do, we will try to do this lab from scratch. Okay, so fundamentally we have CSV file. Mostly in any big data pipeline, maybe using Scoop, you can load RDBMS data as CSV in your S3 data lake, or suppose the source team is giving you the CSV file. Okay, then what we will do first, we will be using that CSV file and we will try to convert to that Parquet file, and then we will try to infer the Parquet file schema using this automation tool. Okay, because currently as of now this infer schema, this particular feature support only Parquet and ORC and Avro. It don't support CSV and JSON. Snowflake developers are still working on that to sort it out. Okay, to add that additional file format support. Okay, right? So now that is not a very big deal. What we will be doing, we will be first taking a CSV file, we will try to convert that to Parquet. So how you can do that? You can simply do using AWS Athena. The default technique, like how we follow in Hive to convert CSV file to Parquet or CSV to Avro or like that, same concept we are going to apply here. Basically, if you just recall how we do in Hive. So in Hive, basically we are having a table, okay, which will point to that CSV location where the data is stored as CSV format, right? And we will be creating this particular Hive external table with the CSV file format technique, and then we will be creating another Hive external table which is having the same schema, but here we will mention that as park it. Okay, that's it, nothing else. And then we will try to ingest the data from the first external table to the second external table. So when from this first external table to the second external table, we will be executing some insert query and the data will be loaded. Because in the table definition we mentioned that the file format expected for the second table is parquet. So what will happen, the data will be automatically converted to parquet and the external table will load that data in that specific location as parquet format only, right? Very simple approach. So let's try to do that. Okay, before that let me show you the data so that you will be getting some idea, and I'll be sharing this data in the description box as well. Okay, so if you see, this is our data. Okay, simple iris flower dataset we have taken, like iris setosa, iris virginica, iris versicolor, 3 different flowers are there. A very simple columns. Okay, only 4 columns it contain, and if you check, first column is id, which is integer, and then sepal length, and then sepal width, then petal length, and then petal width, and the final one is class name. id is integer, next 4 columns are double type, last column is basically string type or varchar type, right? And we'll try to see how Snowflake is inferring this. Okay, right? So first step, what we'll be doing here in the lab section, as you can see, first we will be creating a S3 bucket to store the CSV data. Okay, you can think like this way, that this data might be we are extracting from an RDBMS system. Okay, from RDBMS you have extracted the data and loaded in S3 as CSV format using scoop code. Okay, right? So here let me go to S3, right? And then here as a first step, what I'll be doing, I'll be creating a bucket to store the CSV file, right? So here I'll be creating the bucket. So here I will be doing CSV storer. Okay, right? And keeping all other properties default, here I am creating the bucket. Okay. So here our first bucket is created. Right. In the next bucket, okay. So what I will be doing for parquet, I will be creating another bucket. Parquet store. Okay, I'll be creating the bucket, right? So here parquet store is there, and then for this particular discussion, to convert the CSV file to parquet, I'm not going to use Hive, because Hive generally in EMR you can use this Hive, but I don't want to launch some servers. Rather, I will show you how you can execute the same concept using Athena in a serverless manner. Okay, so the same concept we are going to do. Instead of Hive, we are going to use Athena. That's it. Now to store Athena logs, we need something. So Athena log storer demo, some name I am taking. Okay, I am creating the bucket. Right. Now what we will do as a next step, we will try to upload our sample data in the CSV storer S3 bucket. Okay, so here I will go to CSV storer, and here I will click on upload. I will go to add files, and then here I will go to talent, and then here I will upload our CSV setosa file, right? So here click on upload. Depending on file size and internet speed, it will take some time to upload. Like here it is uploaded. If I go to that place, here our setosa file is uploaded perfectly. Okay. Now what we will be doing? We will be going here, and here we will be going to Athena. Okay, right? And then here what we will be doing? We will be taking a code. Okay. So here this is our external table code, which will basically point to the data, which is CSV file just now what we uploaded. Okay. So as you can see here, ID is integer, then sepal length, sepal width, petal length, and class name. We are specifying this schema here, and then here serialization, deserialization format we are specifying as the default one, that is lazy, simple, serialization, deserialization, and specifying the some formats. Okay, like fields delimiter is comma. Okay, serialization format is comma, and the table properties is has encrypted data is false, because we have not encrypted this data, right? But suppose you are applying server side or client side encryption, then you have to adjust accordingly here. And then here we are mentioning one more thing, that is keep header line count 1, because if you see our CSV file, here header is present. So we want to avoid that. That's simple, right? So here I'll be taking this code, and Athena code is almost same like our Hive code, not that much different. Okay. So here what I will do, I'll be creating a database. First I will drop the database so that drop database hello world, and let me run this one. Invalid operation. Okay, I think I cannot execute like this way. Let me just copy this one and then let me run. Unable to drop, invalid operation, database hello world is not empty. Okay, so basically database hello world, here some data is there, so let me delete these tables. So I just want to make a clean environment to show this demo. That's why I am dropping the database, so that earlier existing stuff will not impact us. Okay, so here I will delete this table also. Right, so here deleted, and then here if I refresh this, here you will see drop it will be drop database hello world. Okay, let's run it again and see it is successful. Okay, then here what we will do, we will create database hello world. Okay, no issue if you used earlier one also, but just for a clean environment I am using that, nothing else. Okay, so here hello world, no table is there currently. Okay, and also I will be change the setting. So here Athena logs I want to store in the S3 location which we created. Okay, so if you see Athena log store demo, this is the one. Okay, let me check what is the name we have given. Athena log store demo. Let me check. Okay, and here I'll be choosing that, and here I will click on save. Okay, and then let me show you currently Athena log store. If we go here, if I refresh this page, here Athena log store demo is there. Currently it is empty, right? Because just now we did setup. Now what we will do, we will try to execute this particular query. Okay, which will point to that external CSV data, right? So let's execute this one. I'll run this one. Okay, sorry, here I have not specified the location, right? So let me give the location. So our data actually stored in this CSV store, right? So here I'll be taking this one, and then I'll paste it. Yeah, now it should work. Let's see. Query success, right? Super. So here I'll be taking this one, and let me open a new window. Select star from this one. If I execute, let's see. So here we are able to see our tabular dataset, right, which is in CSV format. Now what we'll do, we'll try to convert that to Parquet. Okay, and the Parquet code is very simple. Okay, either you can create a table with Parquet file format and then try to execute insert query from that table to this Parquet table, or else what you can do, you can basically use create table query. Okay, I'll be taking the Parquet data where I want to store, and I'll paste that here. So what is the query? Create table hello world.hello Parquet. So currently see hello CSV, only one CSV related table is present in the hello world database, and we are getting one more hello Parquet. Okay, and here we are mentioning the format should be Parquet. External location we are mentioning as select star from hello world.hello CSV. So CSV data we are ingesting in the Parquet file format related external table. Simple approach, right? So here I will run this one. Okay, so here it is stating it is already existing. Okay, right. So if it is already existing, here I can give one more thing, that is Parquet convert Parquet. Right. So let's run now. And here you will be able to see query execution successful. So under the Parquet stored bucket in this convert Parquet folder, we should be able to see the Parquet data. Okay, which is converted from CSV to Parquet. See, convert Parquet is there, and inside that, if we go here, we are getting our Parquet data. To verify, if you want, you can download that, and then here you can use some online tool, like for example this one, online Parquet viewer you can use. So let me just upload and show you. So I will be going to downloads, and this is the one already downloaded. I will open this one. Okay. See, here it is perfectly showing, right? ID, sepal length, petal length, and class name. So what is the conclusion of this approach? Why we used Athena? The thing is, we need to convert the CSV data to Parquet. So first step is done, and now I will show you this Parquet data. Snowflake will automatically infer this schema. So this is not actually part of Snowflake feature. I just want to show you that how Snowflake infer this schema automatically for Parquet files. Okay, or same concept can be applied for ORC or basically Afro file as well. Okay, but just to generate the Parquet file, I followed this approach, right? So the first step is done. We created our Parquet data, and now we'll see how the infer schema is working. Okay, so what is our external stage? Suppose with respect to Snowflake, if we forget Athena, if we forget online Parquet viewer, our external stage is this particular location. Convert Parquet folder under Parquet Storer. There we are having a Parquet file, and we will see whether Snowflake able to infer this schema or not. Okay, and for that, this is the piece of code. Very simple. First, what we are doing? Drop database run. Dropping the database. Okay, just to make it fresh environment. Then create database if not exist RAM. We are creating the database, then we are using the database. Okay. Then here we are creating a file format. Okay, Parquet file format. Simple. Then here we are creating an external stage. For creating external stage, I am using AWS key ID and secret key, which is obviously not a secured approach. You can use IAM role-based authentication. So regarding that, I have explained in detail. But just for demo purpose, I am using user ID password-based authentication. I will be deleting these credentials after the demo. But make sure you are using IAM-based role. And if you want to know how to create IAM-based role oriented external stage, then please check the link given in the description box. Already I have explained in detail. Okay, right? And then here we are using list command to list all the elements of the external stage. Okay, right? And then here, this is the code which will infer this schema. What we have written? Select star from table, infer schema. So infer schema is the function, as I have already shown you in the PPT slide. Here infer schema. Okay, so infer schema is the one. Then here we need to pass location. Okay, so with respect to external stage, what is the location that you need to mention, and the file format. Okay, now one thing you can understand from basic intuition itself, that infer schema is going to give us multiple row, multiple column related output, right? Because it will try to infer this schema for each columns in the Parquet file. It will try to generate one row. So basically infer schema is such function which is not a scalar function. It will basically return us one tabular data. So to get the tabular data, we need to use table keyword, right? Any kind of function which return tabular data, for that we need to use table function. So we are using select star from table and then passing this. Simple code, right? I'll be copying this particular code and I'll be going to my Snowflake account. I'll be pasting that here. Okay. Up to this, I will simply execute. Let's execute that one by one. Okay. So here I will run this. Let's execute them. Now here, external stage. Here you need to give your S3 location. Okay. So here my S3 location is this particular one, Parquet Storer. Okay. So here we are giving the Parquet Storer bucket level. Okay. And passing the credentials and secret key. Right. And file format is Parquet format. If required, you can mention the file format in this stage itself. Otherwise, you can ignore, not an issue. There is no hard rule. Okay. So here I will execute that. Here it is created. Now if I execute list command, here you will be able to see that here it is clearly showing or clearly listing this file which is present inside convert Parquet folder. Okay. Now our aim is checking whether Snowflake able to automatically infer this schema or not. Infer schema in the sense what? ID column should be integer. Sepal length with petal length should be double or float type. Okay. In Snowflake, real is another common word which we use to indicate float data type. Okay, then if it is returning real, that's also fine. And class name should be varchar type or string type or text type, right? So let's see that. So here we are mentioning ramu.public.snowsimple, which is our external stage name. Okay, if you want, you can specify the folder location as well, not an issue. Okay, so like here you can mention the folder location, and then here you can run this particular code. Okay, let's run that and see here the beauty. Okay, Snowflake has automatically inferred this schema. Let's see. See, sepal length. Sepal length is real. Just now I told you real is nothing but float. So what is our sepal length? Our sepal length is float data type, right? Then petal width. Petal width is basically this particular column, which is also float. Class name, which is text, or basically I can say varchar type, right? And then sepal width, which is also real. ID you can see this is nothing but what? Integer, right? So number 38,0, and petal length is also real, because petal length also here we are getting as float data type. Okay, perfectly Snowflake is inferring. Only thing is it is not following the order. Okay, you need to remember this. When Snowflake will infer this schema, it will not follow the order. Okay, that only is the little bit drawback. Okay, right? So now we understood how to infer the schema. Okay, from an external stage or internal stage also you can apply the same concept, right? I hope up to this it is very clear. Now we will try to create Snowflake table using the infer schema. Okay, because our ultimate aim is what? Our main problem was, suppose in external stage or in internal stage, whatever you say, there are a lot of columns are present in a particular file. Then instead of manually creating those, is there any way to automate? And Snowflake told, yes, there is a way that you can use infer schema. So now what we will see, that how to use this infer schema code to create table. Okay, right? So create table functionality is to automatically create the structured table using the detected or using the inferred schema from the staged file with no additional input. Okay, we no need to mention the structure. Like here if you see, in this particular Athena, when we started, here in this CSV file, we need to mention the data type and the schema, right? But now we'll see how this particular inferred schema we can use to generate table. Okay, right? So for that, we'll be going to Notepad and we'll be seeing some code. Okay, all these codes I'll be providing in the description box or in the comment section so that you can also check. Okay, so now the next topic what we are going to learn is how to use this inferred schema to create the table. Okay. Before that, just a quick recap of two very important functions in Snowflake. Okay, so what I am doing here, I am creating a table, demo table 1, and giving two column names, and we are inserting some dummy data. Now if I execute select star, we will be getting this data set, right? Simple tabular data. Now recall one function which we studied while unloading the tabular data as JSON in external stage, and that is object construct. What it does basically, it basically convert the tabular data as object, as key value pair. Okay, so if you see the object construct output, you will be getting like this. So if you see, for this particular table, created date and this particular, these are the two keys which are coming here. Okay, and created days, this particular value is coming here and this value is coming here. Same goes for second row, right? This is one recap which I wanted to discuss. For more details, you can refer the documentation. And another one is array aggregate. Array aggregate, as you know, that it basically convert the whole column to squeeze into one array. Okay, that so like for example, if you apply array aggregate on this particular output, so currently these are individual object. Each row is generating one object. Now you will be getting only one row which contain both the object. Okay, so array element will be individual object. So if you see the array aggregate output of this particular query, here you will be getting this kind of output, right? So as you can see here, this is one array. Here third bracket is opened and here third bracket or square bracket, whatever you say, is closed. And this is one object element and this is another object element with comma separation. Okay. Now you might ask me why I am discussing array aggregate, object construct, etc. functions this time while explaining inference schema property. The thing is, this particular two function, array aggregate and object construct, we have to use in our further discussion. Okay, they are required. So now we'll see that. Okay, so this is nothing but Snowflake syntax. We cannot do anything. Okay, so if you want to create table using inference schema, you have to use this kind of query. Select array aggregate and then object construct star. So we are basically, what we are doing, from the inference schema, tabular data, whatever we have just now seen, on that we have to apply first object construct function. So individual row for individual row object will be generated, and then we have to apply array aggregate as well. So let me show you that. So if I copy this particular code and I will paste that here, if I run this one, here you will see that here that same tabular data, now it is coming as one object, this is another object, and the whole thing is coming basically under one array. Okay, now this one you can use to create table. Okay, and how the syntax will be: create or replace table hello parquet. So I am giving this name, you can give any table name, not an issue, using template. Okay, this is just Snowflake syntax, no rocket science. Okay, and then this particular query, whatever I have shown you here, that you have to. Okay, then only using Inference Schema you will able to create Snowflake table, right? So I hope you got the concept. That is, this particular result set in template function we have to pass to create a table from the Inference Schema. Okay, right? So let's execute that and we'll see. And if I execute now, here you will able to see that table hello parquet successfully created. Right? Now if I do select star from hello parquet, let's see how the data will be. Okay, here we will be getting no data. Why? Because it is just creating table. It has not copied the data, right? It is not an external table, neither we used copy command for table. So how the data will be coming? So now we have to execute the copy command also. Okay, so to load the data you have to execute this query, copy into the table name query, want to copy the data from external stage. Okay, then here file format we are mentioning parquet format. One more thing we have to mention, that is match by column name equal to case insensitive. Okay, because parquet is case sensitive file. Now it will generate the column names also in a case sensitive way. So what I am telling, that you become case insensitive and then you try to match the column names and try to put the data in proper column in this particular table. Okay, because just now we have seen, right, that parquet, whenever the Snowflake is inferring the schema from parquet file, then it is not following the column order. So we need some way to follow the order, right? So what we are saying, that match by column name. So it will try to match the column name of this particular table and external stage, and it will try to load the data with a case insensitive format. Because parquet is case sensitive, so we have to explicitly mention that don't follow case sensitive order. Simple, right? Nothing rocket science till now. And now what I will do, I will paste that one. Okay. So here, let's copy the data, and here see 50 rows got loaded, because in our CSV table, CSV file also 51 rows was there, and first row if we exclude, because first row was headed, so 50 rows only overall we are having. So now if I execute select star from hello parquet, here we will able to see perfectly the tabular data. No individual element wise DDL we have applied. Simple concept we have applied, the Inference Schema property, Inference Schema feature we have applied to get this particular DDL, right? Very simple. I hope up to this it is very clear to you. Now the next concept what I want to discuss with respect to this particular topic is generate column description. Okay, Inference Schema is one feature, create table using template also we have seen. Now you can generate the column description also. Basically it will return the list of columns necessary to create a table, and then on that you can do some kind of here and there concatenation or some change you can do to create table on your own way. And this particular generate column description you can use to create table or external table or even view also, not a problem. Okay, here you can modify the column or data types before you completely create your object. So this particular stuff is give you one more level of flexibility. Simple, it will infer the schema, it will give you the query. Now if you want to do some modification and then use that, or else if you want to directly use, then you can use with create table using template. Okay, right? So let me show you now generate column description feature. Okay, very simple, kind of same what we discussed earlier. Like here also array aggregate and object construct star we have to apply, and then here Inference Schema, same thing. Only thing is here we are applying this function generate column description. Okay, and this particular scalar function takes two arguments. One is basically array aggregate result of the Inference Schema after applying object construct. Another one is what you want to generate. What column description you want to generate, whether that is table, whether that is view, whether that is external table. So that you need to mention in the second parameter. Okay, let me show you that, then it will be much more clear to you. So here all I will do, I will execute this particular query. Okay. So if I execute this query, here you will see that this is what we are getting. Okay. So this is what? This is nothing but column description for any internal table, right? Or managed table by Snowflake, right? That's how we define in any DDL, right? So this one you can use to create your table. Very simple, right? So this is one way. Then instead of table, if you give here view, what you will be getting? Let's give view. Here you will be getting only the column names because view don't require the data type. So here it is not giving the data type. Even here you can give external table. Okay. And if you run here, it will be giving you the external table DDL. How exactly we use DDL for external table, right? There is $1 variant column basically, right? From there we are extracting the sepal length key and then we are typecasting to real. Real in the sense float value. Similarly like that, $1.id. ID column we are taking and converting to integer type. Similarly here class name we are converting to text type. So this one you can copy, and before this particular stuff or before this particular string and after this particular string you can append something and then your DDL for external table will be generated, right? Same like that way here I have written. So for view this is the query, okay, to generate the column description, and for the external table this is the query. And then you can basically generate the complete DDL script using string concatenation. See how I have done. Select, then here we are giving external table name public ID status set, and here we are opening parenthesis. Okay. Then here generate column description array aggregate, this particular feature which is basically generating the column description we are putting here. Okay, this will be executed, and before that this particular string will be appended, right? And along with that we are at the end also we are appending something. What we are appending? We are appending with location @this and Parquet file format. This is obvious, right? Because in external table we need to mention the location and the file format as well. And because this whole thing highlighted one we are putting inside a quotation. Here you can see here one quotation starts and here one quotation end, and here Parquet file when you are mentioning there also we need a quotation. So if you are giving quotation inside a quotation, then replace the inner single quotation with double single quotation. Otherwise compiler will think that here itself the quotation is ended, right? So here we are giving double quotation to avoid the confusion, and then here we can execute this query to get the complete DDL. Okay, so this kind of automation you can do with some simple SQL transformation. So that's all. If I execute now, here you will be getting the complete create DDL. So I can do this copy and I will click here done and I will paste that as it is. Okay. So see here, this is basically our external table DDL which Snowflake has dynamically generated from the Inference Schema approach, right? Sepal length real as this, petal width real as this. So only thing is the column order might not be same, but here the advantage is suppose you are having 120 columns, then you can run this in a single query, just a single select statement you are executing, right? And here you can do select star from this. Here if I run this particular query, here you will be able to see the external table data which is stored as Parquet file in our S3 bucket. Simple, right? Here you see value column is also coming, which is basically nothing but our variant data type. Like here see format is completely different, but due to the DDL here we are casting that's why we are getting in proper format, right? So this Inference Schema feature is still now in preview feature, so you might expect some sort of changes in future, and Snowflake don't support this, that you are using this particular feature in full-fledged in production for automation purpose. But obviously down the line you might expect that this particular feature will rock the world, okay, because this is making our development process, our ingestion process very simple, right? So what you have to do, you have to try it today. If you don't try it, if you just watch the video, it might not make some more sense to you. When you will try it, when you will face some issue, when you will try to explore in Google or in the documentation, then you will be getting more clear idea, right? So this is all for this video. Try it out today. Surely it will help you to strengthen your knowledge in Snowflake and make your life easier. with respect to Snowflake developer, right? This is all for this video. If you find this video helpful, then please like, share and comment. Subscribe our channel if you have not subscribed till now. And don't forget to press the bell icon to get the notification of our latest videos. Thank you.